Hello class. Today we will be covering section 6.4, Prove triangles similar by SSS and SAS. Turn to page 385 and look at number 3. Number 3 says, verify that triangle ABC is similar to triangle DEF. Find the scale factor of triangle ABC to triangle DEF. The first thing I want to do is write a statement of proportionality. So what that means is I'm going to say that AB corresponds to side DE, BC corresponds to side EF, AC corresponds to side DF. And I know that by looking at the way the similarity statement is written. After I write down my statement of proportionality, I want to plug in my values. So for BC, I have 15, DE 10, BC 18, EF 12, AC 12, DF 8. When I simplify all three fractions, I have 3 over 2. So each fraction simplifies to 3 over 2, so the scale factor is 3 over 2. So I know that triangle ABC is similar to triangle DEF by the SS similarity theorem. And you need to make sure you read the theorem on page 382. Number 5. Number 5 says is either triangle JKL or triangle RST similar to triangle ABC. I have 3 triangles here, and I need to know if ABC is similar to either of these 2 triangles here. So I want to again write me a statement of proportionality and actually look at the values. So I know that side AB corresponds to side JK, so I have 7 over 6. Next one, I want to see that BC corresponds to KL. So I have 8 over 7. But I noticed that 7 over 6 and 8 over 7, they're not the same values. So because they're not the same value, that tells me that triangle ABC is not going to be similar to triangle JKL. So I know that triangle ABC is not similar to triangle JKL. So because I know that, it's no need for me to do that third side because they're not similar. Now I want to try my first triangle and my third triangle to see if they're similar. So I see that AB corresponds to RS. So I have 7 over 3.5. 7 divided by 3.5 is 2. And then I can put it back over 1. BC is 8. ST is 4. And that simplifies to 2 over 1. AC is 12, RT is 6. That simplifies 2 over 1. So because all 3 parts are the same, that means they are proportional, and that means that that ABC is similar to triangle RST. Number 7. Number 7 says, determine whether the 2 triangles are similar. If they are similar, write a similarity statement and find the scale factor of triangle B to triangle A. So I'm going from B to A. So I'm going from small to large. If you cannot see the image, then you need to take one of the triangles and rotate it so it can line up with the other triangle. So I notice off the top that I'm dealing with a right angle. So that tells me I know that D and W, they'll go together. When you look at the corresponding sides, you have a small number, larger number, and that's how I want to line them up to help me. So that being said, I know that WY corresponds to DE, which is 6 over 9, which simplifies to 2/3. I know that WX corresponds with DF, which is 10 over 15, which simplifies to 2/3. So the scale factor is 2 over 3, or you can say 2 to 3. So the similarity statement is triangle XWY is similar to triangle FDE. So we know they're similar. Number 9. Number 9 says find the value of n that makes triangle PQR similar to triangle XYZ when PQ equals 4, QR equals 5, XY equals 4 times n plus 1, YZ equals 7n minus 1, and angle Q is congruent to angle Y. Include a sketch. So I want to go ahead and draw my sketch before I actually work out the problem. So when I draw my sketch, I notice I'm dealing with a side, an angle, and a side. Okay? So I know that PQ corresponds to XY, so I set it up that way, equals RQ corresponds with YZ. So if you notice, I set it up that way also. So if you notice, I have a proportion. All a proportion is 2 fractions with the equal sign in the middle. Okay, that's how a proportion looks. Okay, cross multiply. So when I cross multiply, I have 4 times 5 times n plus 1 equal 4 times 7n minus 1. On this next step, the only step I did was I said 5 times 4 is 20. Next step, I'm going to apply my distributive property. 20 times n is 20n. 20 times 1 is 20, equal. 4 times 7n is 28n. 4 times negative 1 is negative 4. Next step, I combine like terms. So my minus 4 moves from the right to left. And it becomes positive 4. The plus 20, the plus 20n moves from left to right, so it's negative 20n. 20 plus 4 is 24, equals 28 minus 20n is 8n. Divide 8 on both sides, which cancel, so the 8's cancel to 1, so n equals 3. So I included my sketch and I solved for n, which is 3. Okay, look at the next problem, number 10. It says, show that the triangles are similar and write a similarity statement. Explain your reasoning. So you need to read Theorem 6.2, side, similarity theorem on page 382. So what I will always recommend is that you separate the image into 2 triangles. But if you can see the image, then don't do that step. But if you cannot see the 2 triangles, you need to redraw it. So I'm going to write another statement of proportionality. I know that HJ corresponds with HK equals GH corresponds with FH and GJ corresponds with FK. That being said, I want to plug in my values. So I have 16.5 over 22 equals 15 over 20 equals 18 over 24. When I simplify all 3 fractions, it simplifies to 3 over 4. So that means that triangle GHJ is similar to triangle FHK by SSS. Similarity theorem. Number 12. On 12, I did take the smaller triangle and I drew it again so that it can line up with the larger triangle. So looking at my picture, I noticed that I have a side, an angle, and a side. And it must be consecutive, one behind the other. A side, then angle, then side. It can't be side, then jump over to angle, then jump over to side again. So you cannot do that. It has to be one behind the other. So you need to read Theorem 6.3, SAS, Similarity Theorem. You need to read that. And that's on page 384. I know that Angle D is congruent to angle G, and that's obvious because they're both 47 degrees. I know that DG is proportional to XZ, and I know that DJ is proportional to GY. So when I plug in my values, 50 divided by 30 equal 35 divided by 21, I notice they all simplify to 5/3. Look at number 15. 15 says, sketch the triangle using the given description. Explain whether the two triangles can be similar. So in triangle XYZ, the measure of angle X equals 66 degrees, and the measure of angle Y equals 34 degrees. In triangle LMN, the measure of angle M is 34 degrees, and the measure of angle N is 8 degrees. A lot of information. So you definitely need to sketch these two triangles so you can include all the information to the triangles. So I know about this triangle sum theorem. I know that angle Z will be 180 minus 66 degrees minus 34 degrees, which equals 80 degrees. So angle Z is 80 degrees. I know that angle L equals 180 degrees minus 80 degrees minus 34 degrees equals 66 degrees. So angle L is 66 degrees. So if I look at this, I notice that my corresponding angles are all congruent. So they are similar by the AA similarity theorem, and we talked about that on the previous section. I know that if I have two angles that are congruent, that means that third angle is going to be, if I have two corresponding angles that are congruent, then that third angle will also be congruent as well. Number 17. In the side lengths of triangle ABC are 24, 8x, and 54, and the side lengths of triangle DEF are 15, 25, and 7x. So I want to apply the SS similarity theorem. So I know that by looking at the information, I know AB corresponds with DE, BC corresponds to EF, AC corresponds with DF. So that's what we're assuming, that they correspond. So when I find my scale factor, I'm going to say, okay, well, I have 24 over 15, and that simplifies to 8 over 5. So that's going to be the scale factor that I'm looking for my other three parts. I know that 8 over 5 equals 8x over 25. When I cross multiply, I have 40x equals 200. When I divide 40 on both sides, x equals 5. When I plug 5 back in for x, I have 8 times 5, which is 40, divide 25, which is 8 over 5. So far, so good. Both of the parts are proportional. Let's do the third one. So I have 8 over 5 equals 54 over 7x. So when I cross multiply again, I have 8 times 7x, which is 56x. 54 times 5 is 270. When I divide both sides by 56, it simplifies to 135 over 28. So I can see some red flags already here. I can see that when I plug 7 back in, it's not going to equal 8 over 5. When you type this in, 54 divide 7 times 135 over 28, it will not simplify to 8 over 5. So I know that triangle ABC is not similar to triangle DEF because the lengths are not proportional. Look at number 25. It says, in the figure at the right, triangle ABC is similar to triangle VWX. So I want to find the scale factor of triangle VWX to ABC. So I want to look at the large image, then the small image. So I need to find two corresponding sides that have values already connected to them. The only corresponding sides I see is VX, and AC. Those are corresponding sides. If you did not see that, you need to redraw one of the images so it can line up with the other image. Plug in your values. 51 over 34. When I simplify, divide by 17 on both sides, it simplifies 3 over 2. So the scale factor is 3 over 2. Last example, number 33. So take a minute and read the question so you can understand what it's asking you to do. Okay? If you look at the picture, I have a person, Ruby, standing with a shadow, and then we have a tree and it has a shadow also, casting a shadow. So if you notice, it forms 2 right triangles. So what I did do is I wanted to redraw that because the picture can be a little tricky to look at. So I redrew my right triangle so I could see the picture better. Going back to question A. Question A says, what postulant or theorem can you use to show that the triangle in the diagram are similar? So if I look at this diagram, I see some things. I see that it says triangle. What I did first is I wanted to name my triangle. So I have ABC and triangle ADE. So for part A, I said that they are similar by the AA similarity postulant. I know that because I see 2 right angles. I also see that the small triangle and the large triangle share angle A. So that means that angle A and angle A from the large triangle, they're congruent also. So I have angle A is congruent and angle C is congruent to angle E. So by the AA similarity postulant, that tells me that these 2 triangles are similar to each other. Part B says, about how tall is the tree to the nearest foot? So they want us to give an answer in feet. But I have a problem here. The units must be the same. I have inches and I have feet. So I have to do some conversions. So I have 66 inches, and the 66 inches represents how tall Ruby is. I want to convert 66 inches to feet. So I know for 66 inches, I know that 1 foot equals 12 inches. Inches cancel. 66 times 1 is 66. 66 divided by 12 is 5.5 feet. If you notice, that's the only unit that's left is feet. So I want to go ahead and set up my proportion. So I know by looking at the diagram, I know that AC is proportional to AE. And I know that DC is proportional to D. BC is proportional to DE. Plug in your values. AC is 7. AE is 7 plus 95, which is 102. BC is 5.5 feet. I don't know DE, which is the height of the tree. I don't know that though, so I put an X there. Cross multiply. 7 times X is 7X. 5.5 times 102 is 561. Divide both sides by 7. So X is 80 feet. It's approximately 80 feet. Now I want you to try C. C is a very similar direction to A and B. So I want you to try C and see if you get the right answer. Okay? So look over these notes and make sure you go back and look over your previous notes as well.